Good morning students. Today we start with Surface Chemistry Unit 5 Part 2. The first topic we are going to deal with is mechanism of adsorption. Now when we look at this picture we can see that there is a molecule inside the bulk, and this molecule inside the bulk is surrounded by identical molecules, and it experiences balanced forces from all the sides. But when we look at this molecule which is near the surface, it is having unbalanced forces because it is not surrounded on all the sides by identical molecules. So what happens? There is a kind of residual attractive force developing on the surface. So these residual attractive forces on the surface of the adsorbent causes the accumulation of adsorbate on the surface. So this is the cause of adsorption. Now next topic is adsorption equilibrium. Now we know that adsorption is exothermic in nature. This is because there is decrease in surface energy in form of heat. So delta H is negative. Similarly, we have delta S also negative. This is because the freedom of movement of molecules of adsorbate is restricted. So now we have to keep in our memory that adsorption is accompanied by decrease in enthalpy as well as entropy. In thermodynamic Gibbs free energy equation, which we have seen last year, delta G is equal to delta H minus T delta S. For a process at constant temperature and pressure to be spontaneous, we all know that delta G should be negative. And if we want delta G to be negative in this situation, we should have delta H to be highly negative. It should be sufficiently highly negative so that delta G becomes negative. This is because the term minus T delta S is already a positive value. But as adsorption proceeds, delta H becomes less negative and it becomes equal to T delta S. At this stage, delta G is 0 and this is the stage of equilibrium. Next we move on to types of adsorption, and this is for gases on solid surface. There are two types adsorption. One is physical adsorption, which is also known as physisorption, and second is chemical adsorption, chemisorption or activated adsorption. Physisorption, it involves accumulation of gas on surface of a solid which is due to weak van der Waals forces. We have already studied about van der Waals forces last year. In chemical adsorption, the gas molecules are adsorbed or held to the surface of solid by chemical bonds. Here we are having a picture which depicts physical adsorption and chemical adsorption. Here you can see the binding site in chemical adsorption, and here we have just the attachment of the adsorbate on the adsorbent through van der Waals forces. Here are few points which you can note down. I will be doing a quick reading of these points. Chemical bonds in adsorption may be covalent or ionic in nature. Chemisorption involves high energy of activation, and so it is often called as activated adsorption. Now, what do you mean by activation energy? Activation energy is the minimum energy required for a process to occur. Sometimes both physical adsorption and chemical adsorption occur together, and it is difficult to find out which type of adsorption is taking place. Sometimes physical adsorption at low temperature may be converting into chemical adsorption as the temperature increases. There is an example here. Hydrogen is first adsorbed on nickel by van der Waals forces, and when molecules of hydrogen dissociate to form hydrogen atom, it may turn into chemical adsorption. Now we have differences between physical adsorption and chemical adsorption. Physical adsorption involves van der Waals forces of attraction. Chemical adsorption involves strong chemical bonds. Physical adsorption has low heat of adsorption. This is because the forces are weak van der Waals forces, and in chemical adsorption heat of adsorption is very high due to the presence of strong bonds. You always have to remember that whenever bonds are strong, the heat evolved will be more. Physical adsorption is reversible in nature. It decreases with increase in temperature. Chemical adsorption is irreversible in nature. Physical adsorption is non-specific in nature. It means that same thing can be adsorbed on different surfaces. Chemical adsorption is highly specific in nature because bond formation cannot occur between all the adsorbate and adsorbents. It is specific. Physical adsorption forms multi-molecular layer. Because one layer adsorbed, the second layer may also get a chance to get adsorbed because there is no bond formation. But in chemical adsorption, monomolecular layer is formed because once the bond formation takes place, the surface is not available for further adsorption. Easily liquefiable gases have high critical temperature and are easily adsorbed as van der Waals forces are stronger near critical temperature. Now, critical temperature is the temperature above which the gases cannot be liquefied by increasing pressure alone. Here we have an example. 1 gram of charcoal adsorbs more SO2 because it has a higher critical temperature of 630 Kelvin than methane, which has a critical temperature of 190 Kelvin. In chemical adsorption, there is no such correlation between adsorption and liquefaction. Physical adsorption has very less or nil activation energy, and chemical adsorption has an appreciable amount of activation energy. In physical adsorption, adsorbate has same state on both surface and in the bulk, and the state of adsorbate differs in bulk and surface for chemical adsorption. Low temperature is always favorable for physical adsorption and high temperature is favorable for chemical adsorption. In both the cases, adsorption increases with increase in surface area. Gases adsorbed on surface of solids is the best example for physical adsorption, and oxygen chemically adsorbed on carbon liberating carbon monoxide and carbon dioxide is the example for chemical adsorption.